Hey guys, welcome back to my channel. Today we are going to be doing the GPU part of the PC build guide. Um, and then I also wanted to let you guys know real quick, the next parts are going to be coming out pretty soon. So we got storage memory and motherboards in one video. And then I'll be kind of going through all of the case and power supply and the less traditional pieces like the coolers, fans, lightings, like those types of things. So those will all be kind of grouped into one video, and then I'll be doing the build video, and then after that I'll be doing monitors and peripherals, as I'm also looking at getting some of those as well in the future. So that's kind of the lineup. It should be within probably the next 2 weeks that most of that is out. So stay tuned, keep an eye out for it. Let's get into it. All right, so talking about the two main companies, we have AMD and NVIDIA. These two are kind of the main powerhouses. They're really the only ones who make anything in the US right now, anything worth their salt. Intel has announced that they will be putting themselves into the market probably next year. It's yet to be seen how much of a competitor they really will be, but it's always good for the consumer to have more options of buying. The more competitive the area is, the better your typical outcome in buying is going to be. So that's good news for us. In the GPU market right now, there's kind of two main trends. So NVIDIA is kind of the high end. They are going to be the most expensive. They have the best parts out there. Whereas AMD is going to have the more price to performance cards. They have, the better budget options, the better mid-range options, and they don't quite have as many bells and whistles per se. And so that's where their marketing is right now. So this is kind of a new change for AMD. AMD was used to be seen as the budget cards, kind of if you couldn't afford a real, NVIDIA card, you're gonna use AMD, and they were kind of the budget. Just like with their CPUs, they've really kind of broken their mold, and now they're really in a very competitive nature with NVIDIA with the GPUs and Intel with the CPUs. So I like to give a lot of props to AMD for the work they've been doing. They're really changing the game right now. So for both AMD and Intel, there are going to be reference cards and third-party cards. So reference cards are going to be the cards that AMD and NVIDIA put out themselves. These are going to be typically they save the best of the silicon lottery winners, basically, and they put those out for themselves, part out everything else to third-party developers, and then they create their own kind of cards around their architecture, named the same. Typically, they have a small overclock on them. Maybe they have a different power delivery system, and usually they have some kind of different cooling solution on them as well. That kind of leads me into the different kinds of cooling solutions. So typically there's three main types of cooling solutions. There's going to be your blower style coolers, which is basically one intake fan that pumps the air over a heat sink and out the back of the card, which is out the back of the computer. The other one is an open air cooler, which is typically 2 or 3 fans mounted on top of the heatsink that is going to circulate air throughout the entire PC case, therefore giving a more even distribution of cooling. And then the third is liquid cooling, typically done as either an add-on piece, so you would have to install it yourself onto another card, or in the newest cases, there are some AIOs that come shipped out with the entire loop being contained within itself. AIO meaning all in one, so it's a completed loop that you don't have to worry about filling or and anything like that. It comes shipped ready to use. So where GPUs kind of differ from CPUs in the whole marketing and naming schemes is that GPUs are kind of a jumbled mess, but NVIDIA has a better naming scheme currently. So they have their naming schemes being, well, it used to be GTX up till the 1000 series. So they had theirs as a generational number first. So it was like a GTX 960. That meant that it was the 9th generation, and 60 was kind of the performance level. So a 1060 would be a generation jump, and then a 960 to a 970 would be a performance jump. So that was kind of how they structured it. And then when it came to their newest gen, which would have been the 11th generation, they decided to change it all, and now they're RTX instead of GTX, and they have their numbers starting from 2060 up, but also they have now added a 1600, so 1660 and 1660 Ti, 1650, a bunch of random cards kind of in the middle to bridge that gap. I'm not sure why they did it, but that is the change in their naming scheme that they've decided. They also introduce the TI suffix at the end. This is going to mean, well, it stands for titanium, but really all it means is it's a little bit of a performance boost on that component. So if you have a 2080 Ti versus the 2080, it's just a performance boosted 2080. So that's kind of the naming for NVIDIA. AMD's is a lot more messed up now. They originally had a similar system with their RX series. So they had the RX 580 and 590. So a 580 to a 590 is a performance jump, and then a 480 to a 580 is a generational jump. But they also always had their additional cards on the side. So they had Vega series, and now they have a Radeon 7, which is really like a continuation of the Vega series. But they also just released their newest cards, which are now called the 5700 and the 5700 XT. So they kind of have ruined their naming scheme, and I think in the future we're going to have to kind of see how they're going to use their new numbering system to have a better line of cards. So something I wanted to mention about GPUs when you're buying is looking at the actual dimensions of your card. So that's going to be something that's actually really important. So it depends on what case you're buying. So typically when you buy a case, you can look up the dimensions, and it'll say it can fit a GPU that is 360 millimeters long. You can look up the GPU and its dimensions, see that it'll fit, and then what you need to worry about next is the what they call slot size. So how many slots it takes up in the PCIe bay. So typically on a motherboard there's multiple PCIe slots, and if you have a GPU that's 2 slots, it's going to take up 2 of those slots in that section. 3 slots would mean it's going into the third one, and that's really important if you're either buying multiple cards to put in using them in conjunction with each other, or if you have other components like Wi-Fi cards or capture cards or something like that where you need another part in there, and if the GPU is taking up all the room, you're not going to be able to fit those pieces in there. So it's important to just make sure that the motherboard and the case can hold as many slots as you're going to need. That's just something really important to look at. The other thing is the power connectors on the GPU itself. So every GPU is going to have some combination of 6 and 8 pin power connectors on them. It's important to know that your power supply is going to have those cables to run to it. There has been issues for some people in the past where They need, two 8-pin connectors, whatever they have, an 8 and a 6, or whatever combination it is. Just making sure that your power supply and your GPU are going to have compatible cords. All right, the last thing I want to talk about is VRAM. So on most GPUs, there's going to be something called VRAM, so your video RAM. It's onboard memory that is put into the card, allowing it to not have to use the RAM that is placed on the motherboard, but rather it can actually just have that data moved quicker because it's right there next to the actual chipset. This can be really helpful, and the more you have on there, it works the same as RAM. So the more you have in your card, the more it can do at any given time. And this is able to be overclocked and things like that, and that's part of how GPUs are overclocked. So it's just good to note that if you're looking at GPUs, some models might have 3 or 4 gigs, and then some might have 6 or 8, and just trying to get the best performance out of it by getting the most RAM on board for the best price. Overall, if you're looking at the newest generation of GPUs, you're really going to just be kind of looking at what each company is offering right now. So currently with this newest stuff, if you're going super high end, NVIDIA takes the cake. There's nothing that AMD makes that's going to really hold up to the 2080 Ti or even the 2080 really. Whereas if you're looking for something where you're going to get a really good solid 1080 or 1440p performance, you can really probably get the best bang for your buck with a AMD, something like the 5700 or 5700 XT. Currently it's a little hard to find the third-party cards, and the reason you'd be looking into third-party cards for AMD is they decided on their 5700X and their 5700 XT that they wanted to use blower style coolers, and the data has been kind of showing that they're not very effective in cooling and they're kind of loud. So a lot of the third-party coolers that have, or third-party chipsets that have come out, are just better overall cooling. They can be overclocked and tweaked a little better, and then they're quieter as well. So if you're looking at a mid-tier, I would wait a little bit longer and get yourself a 5700 or 5700 XT from a third party. That's kind of all I have on GPUs. I know it's kind of a pretty light overview of it, but I think it's just such a complex topic, and I wanted to just kind of do a over-the-top overview of it. So thank you guys for watching. If you have any comments or questions, leave them down in the comment section, and subscribe, like. Thank you.